Everyone says the CPU is dead, that AI killed it. But that story is wrong. Dead wrong, and the truth is a lot more interesting than the headline.
This is the CPU's role in the AI era. It wasn't replaced, it was redefined. And it still owns 3 jobs no other chip can take. Here's our 14-stop tour. The pipeline, why the CPU matters, the memory story, the secret math inside your chip, the players, and the future. First, the pipeline. An AI inference request isn't one operation. It's 5 stages. Load the data, clean it up, run the neural net, tidy the output, and orchestrate the whole thing. Stage 3 is the famous one, but it's only one of 5.
Now watch who actually runs each stage. The CPU handles the ingest, the preprocessing, the post-processing, and the orchestration. The GPU or NPU takes just the middle step. So the CPU runs 4 of the 5 stages. That's about 80% of the real work.
Why does the CPU refuse to go away? 5 reasons. It handles messy control flow natively. It has way more memory. At small batches, it's actually faster. It's everywhere, so it's cheap. And it's already inside every phone and laptop sipping power.
Here's the part nobody talks about. Most AI calls in the world are small and real time. Your chatbot reply. 1 million tiny spam filters. And the failover that runs when the GPU is busy. That's the CPU's volume business.
And here's the irony. Sometimes the CPU is the bottleneck. Decoding images, parsing files, tokenizing text can take longer than the GPU's forward pass. A slow CPU literally starves a fast GPU. So the CPU matters even when it's the limit. Now the memory story. The CPU pairs with big, cheap system RAM. Tons of capacity, modest bandwidth. The GPU pairs with expensive HBM, insane bandwidth but limited capacity. Different strengths, not a fight. Each wins where it should. But the CPU learned new tricks. It went scalar, 1 number at a time. Then vector, 16 numbers per instruction. Then matrix, doing a whole block at once. That last leap gives it up to 64 times more work per clock. The CPU grew its own tensor muscle. Intel calls it AMX. Tile registers plus a single multiply instruction that crunches a 16 by 16 block in roughly 1 op. It's a tensor core, living right inside the CPU, and it's been shipping on Xeon servers since 2023. 3 big extensions make CPU inference real: Intel's AMX, AVX512, and the new unified AVX10, and ARM's SME. Together, they hand the general-purpose chip serious AI throughput, no graphics card required.
The real game changer is quantization. Shrink the numbers, shrink the model. A 70 billion parameter model drops from 140 gigabytes down to about 35. Suddenly, it fits in plain system memory. A 7 billion model in 4-bit fits on a laptop with room to spare.
Microsoft set the bar with Copilot Plus. An AI-PC needs an NPU above 40 TOPS 16 gigs of RAM and 256 gigs of storage. And the proof it works? llama.cpp runs a 7 billion model, quantized on a plain laptop CPU. No GPU, no cloud, just you. Look at the on-device race. Apple's M4 neural engine hits 38 TOPS, Snapdragon X 45, Intel Lunar Lake 48. AMD and Panther Lake both clear 50. Every modern CPU package now ships with its own NPU built in.
That changed the whole package. The old chip was just a CPU and a weak graphics block. The modern AI-PC system on a chip adds an NPU, keeps the graphics, and shares one pool of memory. Smarter silicon, simpler design.
Now the players. Intel is the turnaround story. Panther Lake on its new 18 anode ships a 50 TOPS NPU in over 200 laptops. Clearwater Forest packs 288 cores. And the kicker?
NVIDIA's top AI box, DGX Rubin, uses an Intel Xeon as its host CPU.
AMD is the dual bet. It fights Intel in CPUs with Ryzen and ePike, and fights NVIDIA in accelerators with the Instinct line. The coming MI40X brings 432 gigs of HBM4. Zen 6 lands on a 2-nanometer process. CPU and GPU both gaining share. Then the ARM wave. Qualcomm's Snapdragon X powers Windows on ARM laptops, and it won its big lawsuit. ARM licenses the brains every one of these chips uses. And Apple's M series with unified memory is the proof point that in-house silicon beats the old way.
Behind it all, TSMC makes almost everyone's chips. It's the choke point of the whole AI supply chain. And NVIDIA, the GPU king at $216 billion in revenue, is the perfect contrast. Because even its DGX Rubin needs an Intel Xeon sitting right next to it.
Let that sink in. NVIDIA's fastest AI supercomputer pairs Rubin GPUs with an Intel Xeon host CPU. The GPU does the heavy math. The CPU drives the whole machine. So CPU versus GPU is the wrong question entirely.
The future pulls compute back to the CPU. Agentic AI scales inference, and that needs orchestration, memory, and real-time decisions. Computing goes heterogeneous by default, and on-device AI makes the CPU plus NPU chip the everyday platform.
So don't think versus, think plus. The CPU orchestrates, falls back, and runs the edge. The GPU and NPU do the tensor heavy lifting. Roughly 70% of the job is the CPU's supporting act, 30% is the accelerator's spotlight.
The takeaway is simple. Not CPU versus GPU. It's CPU plus GPU. The CPU didn't lose the AI era. It was redefined into the orchestrator, the fallback, and the always-on substrate. Did the CPU surprise you? Hit like if it did, subscribe for more tech that actually makes sense, and tell me your take in the comments. Thanks for watching.